welcome to the stage Zoe Duran. She's a senior product manager from Databricks. And Yue Zhang, he's a lead software engineer from Block. So today they're going to be focusing on data streaming on the Lakehouse. Can we give a big welcome to these guys? So as these guys are going, we'll leave a little bit of time for Q&A. So there's going to be me and another moderator on the side. So if you have questions, raise your hands, and we'll bring a mic to you so everyone can hear. So, thank you very much. Take it away.
Okay. And then I'll just click that.
Yeah, I can click it.
No, not yet.
Not yet.
Good to go.
You want to click on that yourself to control the pace, okay?
Should we start?
Yeah.
All right, we can get started. Hi, everyone. Welcome to this talk on an introduction to data streaming on the Databricks Lakehouse. You'll be able to discover how you can fulfill all of your use cases, whether real-time analytics, real-time machine learning, or real-time applications, all on one platform. My name's Zoe. I'm a product manager here at Databricks. I work on Delta Live tables, and I'm joined by Yue. Yue, do you want to introduce yourself?
Hey, I'm Yue. I'm a software engineer from Block here to talk about how we've been using their live tables and Block.
Just before we begin, just a quick reminder and a product safe harbor statement that if you wish to purchase Databricks, you should base your purchasing decision based on features that are currently existing, and any forward-looking features are for informational purposes only. All right, now that we got that out of the way, we can get started. Over the last few decades, a lot of the world's processes have moved to the digital world. A lot of the world's interactions have moved to the web, and a lot of the world's data has moved to the cloud. And with this shift, a lot of the world's decisions are happening faster and faster. A lot of the world's decisions are in fact happening in real time. It could be the decision to buy something, which is happening in real time. It could be money transfer, which happens in real time. It could be shipping a good, or it could be a bad player accessing your data in real time. And so all these decisions being made in real time, this is what we're going to address in this talk. It's how you can enable all your teams and all your organizations to make decisions in real time. So where is this real-time data coming from? This data is today coming from a wealth of different systems. It could be data coming from operational systems, records, transactions. It could be data coming in from the web, click data, social posts, emails. It could be data from third-party data services in the cloud that could be relevant to your business. And today, even every sensor, every machine constantly streams data through IoT. And so all this new opportunity, all this new data brings opportunity to build new kinds of applications that integrate and make decisions in real time. This could be things like fraud detection, things like personalizing the offering for your customers based on the latest inventory, or offering smart pricing based on market dynamics. Or it could be predicting when a machine is about to fail and doing that as soon as possible. In other words, the time for data streaming is now. What we've seen at Databricks is that there are 3 types of use cases which our customers have been able to fulfill and that help them unlock new business opportunities. The first kind of such use case is real-time analytics, where the data comes in real time, and every player at the company is able to access it, gain the right insights, and either recommend or make the right decisions based on that data. And one successful integration we've had with real-time analytics has been Walgreens, our customer. The second kind of real-time use case with which our customers have been successful with is real-time machine learning, whereby our customers can score and predict based on the very latest data and act as fast as possible. Our customer AT&T was able to implement real-time machine learning to increase the speed with which they detect phishing, robocalls, and theft. And finally, the last use case is real-time applications, in which these real-time data, real-time use cases are embedded in the business applications themselves. And our customer Edmunds was able to implement real-time pricing based on the latest inventory and based on market dynamics, and this drove a 2x conversion rate for them. And yet, according to IDC, less than 25% of enterprises truly adopt data streaming at scale. It may be possible to implement data streaming for a one-off use case with highly specialized tools, highly specialized workforce, but what we've seen is that it's actually very difficult for enterprises to adopt data streaming at scale and across the organization. And why is that? The reason is that data streaming is very hard. It's very hard for 3 reasons. The first reason that we've identified is that implementing data streaming pipelines requires your data teams to learn new languages, new tools, and to work with different APIs than what they are currently working with in the batch world. The second reason is that building a streaming pipeline and putting it in production, as you probably all know, is extremely complex and often requires stitching together different tools to perform different little bits of the value chain. And this could be things like scaling cloud infrastructure, recovering from failure, monitoring data quality. And so you've got all these different tools that have to interoperate and become quite the operational burden. And the third reason why data streaming is really hard is that oftentimes real-time data lives in one system and is streamed constantly, whereas historical data lives in a data warehouse in completely different systems, completely separate, that have to be governed, maintained, and access controlled twice. And this is also quite a headache for data engineers or data administrators. With the Databricks Lakehouse Platform, data streaming becomes simple. You can enable all of your organization to fulfill their real-time analytics, real-time machine learning, and real-time applications all in one platform. Your data engineers, your data scientists, your data analysts can easily build streaming data pipelines with the tools and the APIs that they already know. Operations and development are greatly simplified. A lot of these complex tasks that we were just evoking, like scaling cloud infrastructure, monitoring data quality, get automated away, and we'll go into more detail in the following slides. And finally, the Databricks Lakehouse Platforms offers a single platform to access, control, govern, and share your data assets, whether historical or streaming data assets. So now we're going to go into slightly more detail into this Databricks Lakehouse Platform and look at the different products that are tightly integrated and play together to inform and realize your different streaming use cases. So everything starts with ingesting your data. Your data may be in a variety of different sources: data warehouses, cloud storage, message buses. With the Databricks Lakehouse Platform, you can easily connect in a native way to cloud storage and message buses and ingest all of this streaming data into your data lake. So you ingest your data. It's written into Delta format, which is our open source data lake storage layer, which brings reliability and performance to your data lake. The next layer, the next product, is Unity Catalog, which is our unified governance and security model, where you can govern, control access to all your data assets, all centrally in one place. You can also share your data assets with other Databricks accounts or even external organizations through Delta sharing, which is our open source sharing format. Next, we have Photon, which is our lightning fast execution engine, which will allow you to process all of that streaming data, transform it really, really fast. Now we arrive at the heart of the data streaming engine, which is Spark Structured Streaming. This is an open source project, which is wildly popular. It provides you with one single API for streaming and for batch data, enabling all of your data teams to work with the tools and the APIs that they already know. And of course, the Databricks Lakehouse Platform offers this as a managed service. Next, we have Delta Live Tables, which is our declarative ETL framework, which greatly simplifies a lot of the operational burden around maintaining infrastructure, recovering from failure, and it creates an incredibly easy and a very simplified experience that enables all of your data teams, including data scientists and analysts, to write pipelines and to maintain them in production. If you combine all this with Databricks SQL, now you've built a real-time analytics engine where all of your teams can have access to dashboards, metrics, all the analytics that they need in real time. And you can also build machine learning models trained on all of this streaming data. You can have online feature stores that are populated with the very latest data, and you can train and perform inference on the very freshest data. And finally, you can also take these prediction scores and you can serve them as an API and embed them into your business processes. And so we've kind of described the Databricks Lakehouse and all the various products ready to serve your real-time analytics, machine learning, and operational needs. We have customers in every vertical that trust us with their streaming workloads. Now we're going to go into a little more detail on why, the top 3 reasons why Databricks customers love data streaming on the Lakehouse. All right, the first reason why our customers love data streaming on the Lakehouse is that it enables your data teams to build streaming pipelines in an easy and fast way. So the Lakehouse provides unified APIs for batch and for streaming, so it requires minimal change to the existing dashboards, the existing notebooks that your teams are already working with, and the APIs and languages are familiar. In Delta Live Tables, we have 2 APIs, a SQL and a Python one, and you can see on the right, this is our SQL API. If you combine a familiar CTAS create table statement in SQL with the streaming keyword, you've basically written enough code to build a streaming data pipeline. And with Delta Live Tables, your data teams can focus on the what and not the how. It's a declarative framework, So it enables your team to just focus on the business logic, and all the, how the data processing is being performed is abstracted away, and they can focus on just writing that business logic. The second reason why our customers love data streaming on the Lakehouse is that the operations involved to maintain, build, and just manage the infrastructure of a pipeline in production is greatly simplified. With Delta Live Tables, a lot of the very difficult aspects of productionizing pipelines are automated away. For example, any pipeline that fails will be automatically retried, and it's not the entire pipeline. We'll retry first the task that's failing, so you don't have to recompute everything. Other things like choosing a cluster size. Choosing a cluster size can be challenging because if your data volume is very spiky, you all have this constant trade-off between having a big enough cluster that it can process the data fast enough and having a small enough cluster that you're not running away costs in a really ineffective way. And Delta Live Tables will manage this auto-scaling for you. So when bigger data volumes come in, infrastructure scales up, and vice versa. We also have data quality as a first-class citizen on Delta Live Tables, where through a framework called expectations, you can define, your data teams have the ability to define data quality rules, and define what is bad data, and they can also decide what to do when this bad data, according to those rules, flows into your tables. You can decide to simply alert, but still let the data come in, fail the pipeline, quarantine the data, or anything in between. And finally, you have access to automated ETL development life with the best CI/CD practices. And the third and last reason why our customers love data streaming on the Lakehouse is for this Unity catalog offering that we have, which provides a unified and centralized governance and security models, which allows you to access and control who has access to your data, whether it's streaming data or batch data. You can also share your data in one centralized location, and this facilitates collaboration. All the data in Unity Catalog is also indexed. It allows your data teams to easily find the data that they need and get to work as fast as possible. And it's not only the data sets that are managed and audited and controlled through Unity Catalog. It's also the other types of assets. It could be notebooks, could be dashboards, could be machine learning models, or even the data pipelines themselves. Unity Catalog is the central governance and security tool to manage all those assets. And finally, our lineage capabilities allows your teams to see and understand the flow of data across all your systems and understand where the data is coming from, which sources, how it's been transformed, and also importantly, when about to modify a data asset, understand the dependencies and what could break from there. Now we'll look into slightly more detail into some of our product innovation that's happening right now at Databricks, which can unlock some more benefits for streaming on the Lakehouse. So we've talked already about Delta Live Tables, which is our declarative ETL framework. So we're doing a lot of innovation right now, but just to recap, Delta Live Tables accelerates ETL development by having these declarative statements for building pipelines with easy to use and familiar SQL and Python APIs. It'll manage the dependencies all in one pipeline. It'll handle retries. It'll manage your infrastructure for you and automate complex and tedious tasks like auto-scaling, recovery from failure, and performance optimization. Like we've said, data quality is a first-class citizen on Delta Live Tables. With our expectations framework, you can define, control, monitor data quality. You can monitor it. You can build monitoring on top of those rules. You can see it over time as it changes, and you can also monitor it across all of your pipelines. And finally, Delta Live Tables provides one single API for batch and for streaming, so it should enable all of your data teams to build these streaming pipelines without changing the way that they work. So Spark Structured Streaming is a wildly popular open source project trusted by hundreds of thousands of individuals and organizations. It's offered as a managed service on the Databricks Lakehouse with a track record of 99.95% uptime. So again, this unified batch and streaming API, it automatically also checkpoints state so that if your pipeline fails, it'll restart from the last checkpointed state, which allows for fast recovery and reliable operations. In terms of performance and throughput, if you use our managed service, we can handle up to 14 million events per second, so it's quite a high throughput at low cost. You can implement also arbitrary logic with our for each batch operator, which is used by more than 40% of our streaming workloads, and implement this arbitrary logic on the output of any streaming query. And finally, we support stateful processing, stateful aggregations and joins, and we support watermarks for bounded state. And the last product we wanted to present is our Workflows product, which is our native orchestration tool, native to the Lakehouse. So it provides a one-stop shop for orchestrating all of your workloads. It's a simple some of the features are a simple authoring flow where you can use either the native browser experience, but also your favorite IDE, and we have full support for CI/CD. You can also have access into the health of every workflow, every task, and have those metrics flowing into your systems. So always know, the state of a pipeline, identify troubleshoot issues, and fix any issues fast. And finally, so we offer this as a managed service on the Databricks Lakehouse, and it has proven reliability, also a track record of 99.95% uptime, and it's trusted today by thousands of Databricks customers who run millions of production workloads. I'm going to hand it over to Yue.
Thanks, Zoe. So I'm gonna spend the next 15 minutes or so to talk about how we've been adopting data live tables and block, or more specifically, how we do change data capture with data live tables. So hopefully give you a better feel of what it looks like to build their live table pipelines. So a short intro of me and my team. So my name is Yue. I'm a software engineer from the Data Foundations team at Block. So our team's mission is to help our internal customers to publish, aggregate, orchestrate data at scale from across the distributed system. So some of the examples of the business use cases our team is trying to support include fraud detections for our Square sellers, payments through the Square seller were P2P payments between Cash App users for risk evaluation. We want to also support real-time loan decisions for Square Capital. Square sellers might want to launch their marketing campaigns for their customers, and we want to also help on that. So for those use cases, we definitely want to have high-quality data, but more importantly, we want to have data that with low latency. We want to have the most recent data so we can, for example, taking into account activities happening for a Square seller to better predict if the next activity is fraudulent or not. So some of the technical requirements, as Block has been consolidating on using Kafka for our data ingestion and Data Lake for our data storage, we want to make sure we sync Kafka streams to data tables in real time. We also want to support event update because some information of the data might not be available at the time of the initial ingestion. And when it becomes available, the upstream publishers want to republish the events. So we will see events with the same identifier, but with different attributes. So we want to support that, or be able to update our rows in our tables. We also want to support simple transformations and data quality check, of course, to make the data in Data Lake with higher quality. So to achieve that, there are a few alternatives we've considered. The first one is Confluence managed Databricks Data Lake Sync connector. It's a fully managed solution with low latency, but it doesn't have change data capture support out of the box. It has limited transformation support, also limited data quality check support. Another alternative we would consider is plain Spark structure streaming. It also offers low latency, has strong transformation capability. You can transform your data with SQL or Spark API. But to achieve our use case, we need to maintain a lot of code for defining your task workflow, define your change data capture logic. We have to implement our own data quality check. We also have to implement our own maintenance job. So with Spark structure streaming, you can end up with a lot of small files. And depending on your throughput, you can have files with various sizes, which might not offer you the best query performance. So we wanna compact and optimize our data in a regular basis. So we need the maintenance job to offer us better query performance. So that leads us to Databricks Data Live Table. The benefits, because their live tables offers declarative syntax to define your pipeline, we believe it can greatly improve our development velocity. It offers other benefits like it's also a managed solution, so it manages the maintenance task for us. It has data quality support. It has advanced and efficient auto scaling. And also, as I mentioned before, has the Unity catalog integration supported recently. And I'll dive a little bit deeper into that in a bit. Here is the diagram showing the architecture of the pipeline at Block. It's a very straightforward diagram with all those real-time events in Kafka topics from various internal services. We have a data live table pipeline which first consumes those events in real time into a bronze table or raw table, and then use their live table API to apply the changes into, or just merge that into a server table with higher quality. The server table will can then be used by other their live table pipelines, or it can be used for machine learning model training, schedule from our prefect, or it can be used for defining your features with a machine learning feature store like Tecton. That's kind of the overview of the architecture. The next I want to show you how straightforward it is to actually implement and build their live table pipelines. So there are two main components of a DLT pipeline: the code and the setting or configurations. As mentioned before, you can define your DLT pipeline with API or Python API. With SQL or Python API. So with Python API, it's really just 3 steps. As I mentioned, we have a row table, a server table, and a merge process. So the first step is to define your row table. As you can see that we are just consuming events from Kafka where we actually do some simple transformations, adding a column. We define a data quality check here, and also define the rule for it. So we want to make sure all events has a valid event ID, otherwise we drop the events. But you can also say, otherwise I want to fail my pipeline. The next step is to define your server table or target table. You define your location or the storage for for your table and how it's partitioned. With those two tables defined, the next step is to define your merge logic. With the DOT API, you just call apply changes. And you give this master or keys column. That's how it knows how to merge those records. If two events with the same event ID, it will take the one with the largest ingest timestamp, or if the ingest timestamp column is missing, it takes the current timestamp to know which event to keep, which event to discard, essentially. The next is, that's pretty much all the code you need to write. The next step is to do your configuration, your setting. You can add those settings from the DOT UI, but you can also upload them as a JSON blob. You only need to do like basic settings like this is what your cluster looks like. I want to have a minimum and maximum number of workers. You also want to have a separate cluster for your maintenance job, which does the auto compaction and auto optimization for you. You want to define if your pipeline runs in a continuous mode or a trigger mode, and you can also enable photon. Library is where your code lives or your implementation, and you also want to give it a storage, which is where your event logs for your pipeline and all your Spark structure streaming checkpoint files are. And that's pretty much it for the implementation. So after the POC, we've been adding a CI/CD process and block to make it more accessible to our internal teams to implement and manage their DOT pipelines. So now different teams can have their implementations as well as their settings there in their own repos. And once they merge, we will call Databricks Pipelines API to create, update, and delete those pipelines in our CI/CD process. So going back to those benefits for their live tables, with the adoption of their live tables, we've seen great improvements of our development velocity. Right now, it spends us only hours instead of days to define and develop a streaming pipeline. It has efficient auto-scaling and managed maintenance tasks for us to give us better query performance and make us more cost efficiency. Recently, it has the Unity catalog integration in public preview, and with that, it can better streamline and automate our data governance. Before this, we wanted to take advantage of Unity catalog, but without the support, we ended up having to have a separate process where we have this pipeline to stream the data into a storage like S3, and have a different process to create a data table out of it. With the integration, we were able to streamline and have the table managed and created from your DOT pipeline directly. So making the process more straightforward and more streamlined. So as of today, at Block, we have about 10 DOT pipelines running daily with about 2 terabytes of data flowing through them. And we have another 150 more pipelines to onboard. So we are excited to see what bigger impacts DOT can offer us. That's my introduction of DOT and Block. If you have any questions.